So hello everyone, this is our lecture for the next week, and in this lecture we are going to continue with the inheritance. We are left with a few more topics with the inheritance like encapsulation and inheritance, and some programming techniques with the inheritance. So we are going to continue with those topics. So let's start with these topics. First topic is encapsulation and inheritance. What is encapsulation? Now, object-oriented programming language. As we know, Java is an object-oriented programming language. Any object-oriented programming language has four fundamental concepts, which are encapsulation, inheritance, polymorphism, and abstraction. Now, inheritance, we know what is inheritance. So when one object acquires the properties and the behaviors of the parent object, that is called as inheritance. Inheritance provides us the code reusability, and it is used to achieve also the runtime polymorphism. Encapsulation. Encapsulation means concealing something. So binding or wrapping up of the code and data together into a single unit. So encapsulation means we want to hide the unnecessary details from the user. We want to conceal something from the user which is not relevant to the user. That is called as the encapsulation. And the third important concept of any object-oriented programming is polymorphism, which we are going to cover in the next chapter. Polymorphism means one task is performed in many different ways. There can be many different ways to perform any task. For example, if we are preparing any program, for example, calculating a factorial, there are many ways to do that program. So that is a general idea of a polymorphism. Method overloading and method overriding are required to achieve the, can be used to achieve the polymorphism. And the last concept of any object-oriented programming language is abstraction. Abstraction means hiding internal details and showing the functionality. That means we are hiding the internal details and we are showing the functionality. So in Java, abstract classes and interfaces are used to achieve the abstraction. So encapsulation. Encapsulation is basically we wrap the data variables and code acting on the data together as a single unit. So for encapsulation in Java, what we need, we need to declare the variables as private. That means all the variables, all the methods, they are wrapped together as a bundle, as a single unit. So for encapsulation, how we achieve the encapsulation? By declaring the variables as private. And then those variables can be accessed by the child class using the getter and setter method to modify and view the variables. Whereas abstraction is we want to hide the internal details. We want only to show the functionality. So encapsulation and abstraction, they are just opposite things. They have just a line of difference between them. So abstraction means hiding the internal details, just showing the functionality, how it functions. Just showing the functionality. That means this functions. Now how internally it is doing, it is not required to show. So that is called as the abstraction. But encapsulation is tying together or binding together as a single unit. So in any object-oriented programming language, the important concepts are encapsulation, abstraction. We will learn encapsulation in this chapter. Abstraction later on we will learn when we are going to learn the abstract classes. Polymorphism in the next chapter. Inheritance we have already done. Classes and objects you already know. So these are 6 main things that make up any object-oriented programming language, which are class, object, inheritance, polymorphism, abstraction, and encapsulation. Now, what are the advantages of encapsulation? So in this topic, we are going to talk about encapsulation. What are the advantages? Advantages are a setter or a getter method can make the class either a read-only or a write-only. That means from a class, either you can read the data or write the data. Of course, you can make the both also, read and write both. You have a control over the data, how the user can manipulate or change the data. It provides the control over the data. It's a way to achieve data hiding. So encapsulation is a way to provide the abstraction. So encapsulation is a way to achieve data hiding. Other class will not be able to access the data through the private data members. So it's a way to achieve the data hiding. Now, for example, if we see this class in this example, we have a class student. It has a private data member which is string name. Then for accessing this member, we have the getter and setter method, which is accessor and mutator methods, which you have learned in the Java 1 class. Then in the main class test, we have created an object of the class student. We cannot access, this class cannot access this variable directly. Rather, it can access this variable with the help of the setter and the getter method. So set method is used to assign a value to the variable, and get method is used to print the value to print the data inside a variable. So this shows a Java class which is fully encapsulated class. It has a private data member and getter and setter methods. A private data member can be accessed with the help of accessor and the mutator method. So a private method is not available and it is not inherited also. So a private method is not available and it is not inherited also. Whereas a private variable can be available with the help of the public getter and setter method. Private method is not available and not inherited. It is only private to that class. It can be accessed only in that class only. Whereas private variable can be accessed with the help of the public getter and setter methods, that is called as accessor and mutator methods. So moving ahead, now this is an example of the read-only class. So here we have only the getter method. Get method is for reading the data. So we have a class student and we have a string variable which is declared as private, and the value is already assigned to this variable. Now when we write the main class, if we use the method s.set method, it will result in a compile time error because it's not defined in the class. It's a read-only class, so we can only call s.getCollage method and it will always return the same value, which is AKG. This is a write-only class. That means we cannot get the value, we can only change the value. We can only assign a new value to the variable, but we cannot print what is inside the variable. This is what we mean by this. So in this, what we have only a set and set method. So for a class, if you want to make it read and write both, you need to have getter and setter, both the methods. So if it has only the get method, it's a read only class. If it has write method, it's a write only class. So it has only write method. So what you can do, when you create the main class and you call this method setCollage, you can only change the value of the variable. If you try to call this method s.getCollage, it will result in compile time error because there is no such getCollage method. But s.collage also, you cannot access this variable also, this college, because it's a private variable. So it cannot be accessed from outside the class. Now let's talk in detail about the access modifiers in detail. So talking about access modifiers. Now there are two types of modifiers in Java. First one is the access modifier and another one is the non-access modifier. Now access modifier, it specifies the scope of a variable or a scope of a method or a constructor inside the Java class. We are going to talk about access modifiers, not the non-access modifiers. So there are basically four types of Java access modifiers: private, default, protected and public. Now private, any data member which is declared as private is accessible only within the class. Default is accessible only within the package. Protected is accessible within the package, outside the package, but through inheritance. So outside the package, it is available to the subclasses only. but inside the package it is available to every class. But outside the package only to its subclasses, not to other classes. Public is accessible everywhere. So there are many non-access modifiers also, such as static, abstract, synchronized, native, volatile, transient, etc. We are not going to cover that. We are just going to cover the access modifiers. Now, a class cannot be private or protected, except the nested class, they could be private. So a class, you cannot make it as a private or a protected. If you don't use any modifier, it is called as a default modifier. If you don't use the keyword private, protected or public, it is called as default. So if you use, for example, private int a, so a is private type. If you use protected int a, integer a is protected. Public int a, integer a is protected. But now if you use int a, the access modifier of integer a is default. So if you don't use any of the keyword private, public or protected, then it is called as default. A protected access modifier can be applied on the data member, on the method and the constructor. It cannot be applied on the class. So protected can be applied on data member, method, constructor, but not to the class. So these are the 4 access modifiers which we are going to talk about in the detail, and we are going to do some of the programs also. I will be running some programs also. So let's first of all understand what we discussed in the previous slide. So let's assume that I have some package. Now this is the availability of this package. That means just consider a package as a box. So in the same package I have class A, class B and class C. So these are in the same package, whereas class D and class E, they are outside the package. Alright. So in class A I have variables V1, V2, V3 and V4. V1 is public, V2 is protected, V3 is default, it has no access modifier, and V4 is private. Now let's check to which of these classes all these variables will be available. So which variable can be accessed by class B, class C, class D and class E. Alright, just keep in mind that class A, class B and class C, they are in the same package. Package means a type of box, you can just consider. Alright, so public according to the definition, available everywhere. So it can access V1. Protected according to the definition, it's available inside the package. So because class B is in the same package, class B can access it. Default can also be accessed over here. Default can also be accessed. So the default variable, which is V3, default is available only within the package. So class B is inside the package, we can access V3. Last variable, which is V4, it is private, so class B also cannot access directly variable V4. It can access it with the help of public get and set methods. Now coming to class C. Class C extends A, so that means class C is a child of subclass of class A and it is in the same package. So class C can extend public variable, which is V1. Class C can extend protected variable, which is V2. Class C can access default variable also because class C is in the same package, but it cannot access the private variable, which is V4. So the same rules, almost the same rules apply over here. Now coming to class D. Class D is also a child of A, but it is outside the package. So class C is also subclass of A, class D is also subclass of A, but class C is inside the same package or the same bag where the class A is, whereas class D is outside the package. So now let's check. Class D can access public because public can be accessed anywhere. Class class D can access the protected variable also, because it can be accessible within the package and outside the package to the subclass only. So since D is a child of A, D can access variable V2 also. Now coming to variable V3. V3 is default modifier. Default modifier is accessible only within the package. So class D cannot access V3 variable. Of course, V4 variable is private, so it cannot access it. Now coming to class E. First thing about class E is outside the package. Second thing about class E, it is not a subclass of class A, right? Class D was a subclass of class A, although it was outside the package, whereas class E, it is neither in the same package as class A nor it is the subclass of class A. So let's check which variables are visible. Class E can access V1, whereas it cannot access either variable V2, V3 and V4. Why? Because it is neither the subclass of class A nor it's in the same package. That's why all other variables are not visible. So let's come up to this table. So visibility from the same class, public, protected, private, default, yes. So in the same class, all these variables are accessible. From any class in the same package, like I have class B and class C, they are in the same package. Public is visible, protected is visible, default, private, no. From a subclass in the same package. So for example, this is a subclass, class C, it's in the same package. Public can be accessed, protected can be accessed, default can be accessed, private, no. From a subclass outside the same package. So class D is a subclass of class A, but it is outside the package. So it can access public, protected, but default and private, no. Last one is from any non-subclass class outside the package. So class E is a non-subclass and it's a class outside the package. So it can access only public variable. Rest other variables are not accessible. But protected, default and private variables are not accessible. So I have certain examples over here. I will just run these examples. So I'm going to run the examples for the access modifiers over here. How does the access modifiers work? We are going to check it. I'm going to execute few programs. So here we have the examples. First of all, I will cover the public members. So I have class A and B in the different package. I have class A in the different package. Class A is in the different package, package 1, and class B is again in the different package, which is package 2. I will import package 1. And let's see whether, and class A does not have any variable, it has a method. I'm going to work with the methods. So public method. So let's just check it, whether the method is available or not. Alright, so it's available. So now in this, the method is declared as public and we are allowed to access the member from anywhere in the package or outside the package. So the corresponding class must be visible before checking the member availability. Now the class A is declared as public, then class B compiles fine and prints the message. For example, now the default, these modifiers are applicable to the classes also. Now here I have declared the class A as public. Now for example, if I remove this public keyword from class A, that means this is the default access specifier for the class. Now let's see what happens. The member will not be available to the class B. So if you see over here, package 1A which belongs to class A is not public. So that method is not available outside the outside the it is not available, it cannot be accessed from outside the package. So because it's a default, I have not declared any public keyword before the class, which makes the class as default, so its method cannot be accessed from the class B. So all these access specifiers, they have to be used carefully with the class. I cannot make a class as private. I cannot run it. So now when I run it, the same thing. So if I declare the class as default, this program will give me an error. That means if I remove the access specifier, it will give me an error. Now moving on, that was about public. Alright, now moving on to the private members. I'm going to talk about members. So I have class A over here. Class A is in the package 1. Class A is in the package. So in this example, class A is in the package 1 and we have one method which is myPrint method, and this is made as private. Now we have another class which is class B. Now class B is in the same package. It is in package 1. Class A is in the same package. They are both the classes, they are in the same package. Alright, now when we try to access myPrint method which belongs to class A, we cannot access it because the method is declared as private. So the method needs to be declared as public if we want to access it. So private methods or the variables, they can be accessed inside the class only, not outside the class. So moving ahead. So this was about public and private. Now moving ahead, let's talk about protected members. Alright, so I have all these classes A, B, C, D, E and Z. I'm going to open all these classes. Alright, so these are the classes. Alright, so I have a class A which is in the package 1, and it has a protected variable and a protected method. Now I have other classes, class B, class C, class D, class E and class Z. Now we will check to which of these classes it's available and these classes are in which package. So these classes are in which package. Alright, now moving on, I have class B. Class B is in the same package as class A. So let's check whether it is available, because protected members, they are accessible within the package, so it must be available. Alright, so it is available. So protected data member is available inside the same package. So if you see, we are accessing the variable also, we are accessing the method also. In class A, I have declared both the variable as well as the method as the protected. Now going on to class C. Alright, same thing is with the class C also. Class C is in the same package. It is just accessing the method and not the variable. Let's check. It will work also because it's in the same package. So it works. Now class D. Class D is in the different package. So moving ahead to class D. Now class D is in the same package as the class A, but class D is a child class or the subclass of class A. So protected variables, they are available to the child class in the same package. So age and myPrint method, both are protected, and let's check whether it is available inside the D class or not. It should be available. Let's just run it. Yes, it's available. So protected members are available to the subclasses in the same package. Now moving ahead to class E. Class E is in a different package. Pack 2, it's in a different box, it's in a different package. Of course, we have to make the import statement. But class E is a subclass of class A. So protected members are available outside the package but to the subclasses through inheritance. So here you will see that both the protected members age variable and myPrint method, they are available. So they are available. I'm not printing the value of the variable, but it does not give me an error. Now suppose, let me just remove this inheritance. Now class E is outside the package. It's in the different package and it's not the child class or the subclass of class A. So it will not be available over here. So it is available only through inheritance. Alright, now moving to class Z, we have a class Z. Class Z is in the different package. Also, it's not the subclass of class A. So none of the protected members, which is the variable and the print method, will be available over here. So because age has a protected access and myPrint method has a protected access, so that's why it's not available over here. Now moving ahead to the next modifier, which is the default modifier. Alright, so default members. So let's discuss. As we know, the default modifier is accessible only within the package. So we have class A and class B. Class A is inside the package pack 1 and we have print method, but we haven't used any keyword public, private or protected. So that means it's a default method. Alright, so we have another class which is class B. Class B is outside the package. Now class B is using the myPrint method, accessing the myPrint method of class A, and this method is a default method. It does not have any access modifier. So it will not be available outside the package. So this method needs to be declared as public in class A if we want to access this method outside the class. So this is how all the access modifiers work. So resuming our presentation, let's continue with this. All these examples are given over here in the slides also. I'll quickly go over these examples. So private access modifier, they cannot be accessed outside the class. So for example, we have a class A. These are the different examples from what I showed to you. It has a data member which is private and the method is also private. I have another class, test class, and I have made the object of class A. Now if I want to access the variable data or the method, it will give me a compile time error. Private constructor, class constructor, if you declare the class constructor as a private, you will get a compile time error. So declaring a constructor of a class private will result in the compile time error. Moving ahead, default access. So we have a class A, it is in package A, some package, and it has one, this is the same example which I have just discussed. It has method which is default access, default method, and I have class B which is in another packet. Now when it tries to access this message method, it will give a compile time error because it's a default method. And also if you see in front of the class, we haven't declared any access modifier. So default classes also I cannot make a constructor of any default class outside the class. Protected access. Now protected access, suppose we have a package, I have a class A and I have a protected method, and I have a class B in another package, and class B is the child class of class A. So child class of class A, this protected method will be available in class B, although the class B is in different package, but because it's a subclass of class A, so it's available. Public access modifiers, they are available everywhere, inside the package, outside the package. Alright, so there are few rules of thumb while you are doing programming, what to declare as private, what to declare as public. Some few rules of thumb I am going to explain you. Use public if the field is to be visible everywhere. If you need the field, want to make the field visible everywhere, make it public. Use protected if the field is to be visible everywhere in the current package and also in the subclasses of other package. Use default if the field is to be visible everywhere in the current package. Use private protected if the field is to be visible only in the subclasses regardless of the package. Use private if you don't want the field to be visible anywhere except in its own class. So these are the few rules of thumb which you must use when you are doing programming with inheritance. Now let's discuss about another topic, which is programming with inheritance. What are some rules of thumb and what are some concepts when we are programming with the inheritance? A class may contain any of the following type of the variables: local variables, instance variables, class variables. Class variables are also called as static variables, although these type of variables we have discussed in the previous Java course also, Java 1. Local variables, the variables which you define inside the method, inside the constructor, inside the blocks, they are called as local variables. And these variables will be declared and initialized within the method, and the variable will be destroyed after the method has finished. So for example, you have created a print method, and inside the print method you have declared a variable. So that is called as the local variable. Instance variables, variables which are declared within a class but outside any method. So when you declare a class, public class A, and after that you declare any variable, that is called as the instance variables. Now these variables are initialized when the class is instantiated, and it can be accessed from inside the method, constructor, blocks of that particular class. Class variables are also called as static variables because they are associated with the class. Variables declared within the class. Now the difference between instance and the class variable is that class variables are always declared with the static keyword. So public static int a, something like this, that is a class variable. So advantage is it makes your program memory efficient and gets memory only once in the class area. Static variables in the parent class are inherited by any child class. So these are the three types of variables which normally you create in your Java program. Object versus class, some of the concepts or some of the differences between class and the object. Object is an instance of a class. For example, we have a class called person, employee is a person, faculty is a person, student is a person. Class is a blueprint or a template from which objects are created. So for example, building is a class. Now house is a building, shopping mall is a building, hospital is a building, office is a building. Object is a real world entity such as pen, laptop, mobile, whereas class is a group of similar objects. For example, I have a class bird. A parrot is a bird, sparrow is a bird, crow is a bird. So object is real world, whereas class groups them in groups the similar objects. Object is a physical entity, that means it's physically existing. Class is a logical entity. So for example, class human beings. For example, any male, any female, any student, any faculty, any employee, all of them, they are persons. Object is created with a new keyword. For example, we have a class student. Student S1 is equals to new student. So new keyword is used to create an object. Class is created by using the class keyword. Object can be created many times. You can create an object of a class as many times as you want, but class is declared only once. Object allocates the memory when it is created, whereas class does not allocate memory when it is created. There are many ways to create objects in Java, such as new keyword, new instance, method, clone method, factory method and deserialization, whereas there is only one way to define a class in Java, and that is the class keyword. Moving ahead, now object classes in Java. Some of the parent classes of all the classes in Java by default, just for your information. Get class. Now it returns the class object. This class can be used to get the information of this class. Hash code. It returns the hash code number. Boolean equals. It compares the object. It compares the various objects. Protected object clone. It creates and returns the exact copy. Clone always means copy of the object. ToString method. We have learned in Java 1. It returns the string representation of the object. Notify. It wakes up a thread. Notify all wakes up all the threads. Wait. It causes the current thread to wait. And wait again, but it has various parameters. And last one is finalize. It is used. It is invoked by the garbage collector for the object to be collected. All right. So moving ahead. Now we have two special methods, equals and string. Although we have discussed in Java 1 also. Equals, it returns true if the two objects are equivalent. Alright, so for example, I have created two objects of class student1. For example, student S1 is equals to new student, and in S1 I have the name as S1 holds only the name of the person, which is Ali, and I have created an object S2 of the student class, and this also holds the name Ali. So when I use the equal method, is S1 equals S2, so it will return me true if both the objects they are equivalent. So public boolean equals true, so return it. We are comparing the object of one class with the object of the other class, and if both the objects are equal, that means they hold the similar thing, it will return true. ToString method. It is used to return the string representation of an object, so it will return what is stored in title, author, rating. We have a string representation of any method, so it will return the string representation of the object. So for example, we have a circle and we have radius r, color C. So radius r, and calling the toString method explicitly. In the class we can use like this, c1.toString method. In the class we can use it to call this method. So the toString method is called implicitly when an instance is passed to the println method. So when we pass, for example, object, if I pass it like this, system.out.println c2, it will call the toString method implicitly and it will print the object representation. It will print its string representation of the object. So both these two statements are equivalent. Alright, moving ahead. Instance of. Now we have another method which is called instance of. It is used to test whether the object is an instance of the specified type or subclass or interface or not. It is also known as comparison operator because it compares the instance with the type. It returns either true or false, and if we apply instance of operator with any variable that has null value, it returns the false. So it compares whether it's an instance of a class or not, or a subclass or not. It will return us true or false. So the syntax is object or the reference variable. We will use the keyword instance of and followed by the class or interface type. For the time being, we will know class type. So for example, if I have a class simple and I make the object of class simple as S, and in the println I write S, which is the object of class simple, instance of simple1, right? Simple1 is the class. So because object belongs to class simple1, so it will return me true. So we are going to check whether this object belongs to this class or not. For example, I create another object of the class. I create an object of the class called simp s, right? It's not simple. Then I check, is s instance of simple one? It will return me false. Why? Because this object does not belong to this class. So here we have more examples for instance of operator. Alright, so let's understand this instance of operator more. So for example, I have a class called vehicle, and I have a main class. I have a class called car extends vehicle. That means class is a child class of vehicle. Now I make an object like this, vehicle A is equals to new car. I am going to cover this concept in the next coming slide. This is a polymorphism. Now when I try to check A is an instance of car, does object A belongs to car? Yes, A is an instance of car, so it will return me true. Another example is, for example, I create a class test. I have a string variable name and it has chains. And if I write name is an instance of string class, that means the data type of the name is string, and when I print it, it will return me true. So we can check the object belongs to that class, subclass or not. Now the one example, the object that I have made over here, I am going to discuss this particular syntax now, which is the concept called upcasting and downcasting. The more elaborated concept we are going to learn in chapter 8 in the polymorphism, but just a glimpse of it I am going to give you over here. Normally what happens, we have a parent class and child class extends from parent class, and when we write the test class, what we do, when we create the object of the child class, we write as child C is equals to new child. That is the way we are writing it. Now we have another way also. So for example, I create in this line, for example, we have now two concepts called upcasting and downcasting. Now what are these concepts? First of all, we understand this. Let's talk about first of all typecasting. Typecasting is a concept which we have learned in Java 1, where we have converted the double into integer or integer data type into double, and so on, float into double, double into float, float into integer and integer to float. That is called as typecasting. Typecasting means converting the variable of one data type into the another data type. So that is called as typecasting. We have learned the typecasting for the primitive type of variables in the in our last course, which was Java 1. Now here we are going to learn the typecasting for the non-primitive variables, for example the objects of the classes. So let's first of all understand what is a typecasting. Typecasting is one of the important concepts which basically deals with the conversion of one data type to the another data type. It can be implicitly or explicitly. So we are going to talk about the typecasting for the object over here, downcasting and upcasting. Now just to remember, what is upcasting? Upcasting means when a child is casted as a parent, that is called as upcasting. When the parent is casted as a child, that is called as downcasting, because think of it that child is given a status of a like parent. So that means the status of child is improved, it is upcasted. Parent has been degraded from its status to the child, so it has been downcasted. So upcasting is the typecasting of a child object to a parent object. Upcasting can be done implicitly. Upcasting gives us the flexibility to access the parent class members, but it is not possible to access all the child class members using this feature. Instead of all the members, we can access some specified members of the child class. For example, we can access the overridden methods. Downcasting. Downcasting means the typecasting of a parent object to a child object. Downcasting cannot be done implicitly. Downcasting cannot be done implicitly. So simply saying, casting of a child as a parent is called as upcasting. Casting of a parent as a child is called as downcasting. Okay, let's think of an example. So let me just give you an example. Let's assume that there is a parent class. There can be many children of a parent. Let's take one of the children into consideration. The child inherits the properties of the parent. Therefore, there is a relationship because there is a relationship because there is a relationship between child and parent. So therefore, child can be implicitly upcasted to the parent. Now let's think other way round. However, a parent may not inherit the child's property. Normally it happens, you inherit the property of your parents. Parents do not inherit your property. But in case, let's consider, parents inherit the child's property. However, we can forcefully cast a child to a parent, which is known as downcasting. So normally it does not happen that parent inherits the properties of the child. So it is, if it happens, we are forcefully doing it, that is called as the downcasting. After we define this type of casting explicitly, the compiler checks in the background if this type of casting is possible or not. If it's not possible, it will throw a compile time error. So now let's learn how to do upcasting and how to do downcasting. So upcasting is child is casted as a parent. So here in the first syntax, object of parent type, we have made an object of parent type and it is equated to child. That means child is upcasted to parent. Now in this case, child C is equals to new parent. That means parent is casted as a child. It cannot be done like this. But this statement is true. This cannot be done like this. It will give you a compile time error. So upcasting can be done explicitly. That means no special syntax is required. Whereas downcasting cannot be done. So we need to have some different statement. How it is done? Name of the child class followed by the object, then name of the child class in bracket followed by new keyword followed by name of the parent class and the brackets. This is done as downcasting. Now normally in the coming examples and in the coming chapter 8, we will be doing upcasting and not the downcasting. So same thing was happening over here. Vehicle is a parent class, car is a child class. So in this, car class is upcasted. Car is upcasted as vehicle, which is completely legal. Alright, so let's just know more examples. Downcasting and instance of. So for example, I have a class parent over here and I have a class child over here. Child class has a method. Now I have a public static void main. I have a show method over here and it's a static method and it takes the object of the parent class. Now we are checking if P instance of child. Now here we are doing the downcasting. So child B1, child P. Now in this case, this is upcasting. So when we call the show method using the parent class object, when we call this method, it will check if P is instance of child. Yes, P is instance of child. It will print it will call over here the method success and print successful casting. Alright, we have another example, downcasting and upcasting. So we have a class parent, we have two children, child 1 and child 2. So in the main class, we have made the object of the parent class as normally, we have made the object of child class normally, we have made the object of child second normally. Now let's do the instance of operator. Is C1 instance of parent? Yes, because C1 belongs to the child class. C1 is a object of the C1 is an object of the parent class. C1 instance of parent, yes, it's C2 instance of parent, yes, because it is inherited from the parent class. Now let's go over here in the third line. Is P instance of child? Has parent inherited from child? No. Is P instance of child 2? No, it's not instance of child 2. Now let's do upcasting. So P is equals to C1. That means child 1 is upcasted as a parent. Now let's check. Is P instance of child 1? Yes. Is parent instance of child 2? No, because child 1 has been upcasted. Now parent becomes instance of child 1 but not of child 2. Let's do it other way around also. Now let's upcast the child 2. So now P will be the instance of child 2 class and not the instance of the child 1 class. Now we have two things, is a relationship and has a relationship. Alright, before we go ahead, so before going ahead, let's just sum up what is the difference between equals method and instance of operator. The main difference is that instance of will return true if object has a inheritance of the class, whereas equals method will check if both objects are strictly the same class or they hold the same thing. So this is the main difference of equals and instance of operator. Alright, now another important concept is a versus has a relationship. Inheritance is a relationship. Composition, there is another concept called composition that is called as has a relationship. A derived class demonstrates is a relationship. So inheritance is a relationship. Employee is a person. Faculty is a person. Person is a human. Sparrow is a bird. So it defines the relationship between the parent class and the child class. Forming is a relationship is a way to make more complex class out of a simpler class. For example, we can say that hourly employee is an employee. Full-time employee is an employee. Hourly employee is a more complex class as compared to the more general employee class, because in employee class you can have like fields like name, social security number or the ID number and this. Now in the hourly employee you have to calculate how many days it worked, how many time it worked, what is the daily rate, or how much it should be paid. So subclass or the child class is a more complex class out of a simpler class, which is the class employee. Another way to make a more complex class out of a simpler class is has a relationship. This type of relationship is called as the composition. It occurs when a class contains a instance variable of a class type. So if I have a variable of a class type, that is called as composition. For example, I have an employee class. It contains a variable called hire date, which is of the date class. I have a employee class. So therefore employee has a date. So we express this relationship by saying that employee has a date. Using has a relationship to build a class, such as we can build a class employee by using date as an instance variable, is called as a composition, because now class hourly employee inherits the instance variable of type date from the class employee. It is also correct to say that hourly employee has a date. So hourly employee is an employee and has a date. So if the two classes they have a has a relationship, that is composition, and if the two classes they have is a relationship, that is called as the inheritance. Alright, so moving ahead. So both the kind of relationships, they are commonly used to create complex classes and within the same class. So if the hourly employee is a derived class of class employee and contains the instance variable of class date, then hourly employee is an employee and has a date. Alright, now static variables. We have discussed the static variables or class variables. They are inherited. Static variables in a base class are inherited by any of its derived classes. Modifiers public, private and protected and the package access, they have the same meaning for the static variables as they stand for the instance variables. So going ahead, so this is all about this chapter. Any your concerns will be answered in the live class. So thank you so much.